Great, as promised, in these slides, we're going to talk about covalent bonds and their dot structures. There are two types of bonds again, ionic, which the previous slides addressed, and these things called covalent bonds. That's what these slides are going to address. So we're going to define it. We're going to represent it in dot structures in these slides. We'll do the whole thing. So let's first define covalent bonds. And so in a covalent bond, electrons are shared between atoms to obey the octet rule. And so how it differs from ionic bonds, electrons are transferred, but in covalent, they are shared. Again, the differences are in red here. All right, so we're going to go ahead and we're going to do a dot structure to represent sharing of electrons in a covalent bond. So this compound here is called methane. It has one and always you refer to the periodic table to get the number of valence electrons. And so carbon here, so group 14, that's 4 valence electrons. Hydrogen, group 1. So what I would do is start an element inventory. We have two types of carbon. Each carbon has 4 valence electrons. In this compound, you only have one carbon. Here. 4 times 1 is 4. So there's a total of 4 valence electrons. Hydrogen, each of them has 1 valence electron. You have 4 of them because it's 4. And so all these 4 hydrogens contribute 4 valence electrons because 4 times 1 is 4. Then you add these up. 4 plus 4 is 8. And then now you're ready to do the dot structure for covalent bonds. So between these atoms, hydrogen can never ever be a central atom. It always has to be on the peripheral because it is in group 1, which means it has 1 energy level, and the first energy level can only house 2 electrons. And so it has to be, all these hydrogens have to be connected to carbon. It's the only option there is. So you put carbon in the middle. You write 1C because there's only 1 carbon, and then you're going to put 4 hydrogens because there's 4 hydrogens that are in this compound. So each of these hydrogens has to be connected to carbon. And so you draw a line. Each of these lines represents 2 electrons. And this represents a covalent bond. That means that these 2 electrons are being shared by this hydrogen, and also, they're being shared between this hydrogen and this carbon. These 2 electrons here that are represented by a straight line here are being shared between this hydrogen and this carbon. These 2 are shared by this hydrogen and this carbon, and then these 2 electrons are shared by this hydrogen and this carbon. So then after this, you need to count up total how many electrons you wrote with these lines. So you put 2, 4, 6, so you represent 8 valence electrons, which is the total number of valence electrons that you're able to represent in this compound. And so you cannot write any more electrons. And so the next thing you need to do is verify that these elements satisfy the octet rule. And so hydrogen, again, it's an exception. It's in period 1 and has only 1 energy level, and at most can have 2 valence electrons that can be housed in the first energy level. And so if you look around here, each of these hydrogens all have 2 valence electrons because each of them are sharing 2 electrons with this carbon. And so this satisfies the hydrogen because each hydrogen has 2 electrons, and now it has an electron configuration of that of helium, which is stable, and it's the only other element that's in period 1. And so each of these hydrogens is fine because each of these has 2 electrons shared by this carbon. And so the next thing you need to do is check to make sure that carbon satisfies the octet rule. So you have 2 electrons here, 4, 6, 8. This carbon has 8 electrons, and it satisfies the octet rule. So this is the dot structure for methane. Okay, example number 2. So this compound has 1 nitrogen and 3 fluorines. So you got to locate on the periodic table. Nitrogen has 5 valence electrons. Fluorine has 7 valence electrons because it's in group 7. Then you do an element inventory with respect to the valence electrons that you got from the periodic table. Here's the number of atoms that are represented in the compound. And then these are the total number of valence electrons that each of these elements contribute based upon how many valence electrons they have and how many there are. And you take this number, you add them up. So you have 26. You can only represent 26 valence electrons in the dot structure. So here, which fluorine is part of, is they can never be center atoms. They always have to be on the peripheral because they have 7 valence electrons, and they can only pick up one more electron, making a single bond. So they have to be on the peripheral. Center atom in this case. Write 2 fluorines, 3 fluorines. So you have to represent fluorine. These have to be all connected to nitrogen, so you connect them. And so each of these covalent bonds you just wrote, this is 2, 4, 6 valence electrons. And so you already represented 6 out of these 26 valence electrons. So you have 20 more valence electrons to represent. And so then you go around and you put dots around each of the atoms to satisfy octet rule, but you can only write 20 dots at this point because you already represented 6 electrons in these lines. So you go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I can't write any more dots because I just wrote 20 valence electrons. And so you go around, you've got to make sure everything satisfies octet rule because there's no exceptions in here. 2, 4, 6, 8. This fluorine is fine. 2, 4, 6, 8. This fluorine is fine. 2, 4, 6, 8. This fluorine is fine. 2, 4, 6, 8. This nitrogen is fine. Lastly, one more thing I would do is just make sure that I did not exceed 26 electrons represented on this dot structure. So 2, 4, 6, 8, 10, 12, 14, 15, 18, 20. So I represented 26 electrons. I did not exceed that, which is correct. So this is the dot structure.